Hi again. In this lecture we will study a method for selecting the size of a single gear electric drive system which meets a set of performance requirements. The method starts only from a given maximum speed of the electric machine and assumes we can freely select the maximum torque and maximum power of the electric drive. It also assumes that the drive will be capable of producing constant power in the whole field weakening region. Assume we want the vehicle to fulfill the same performance requirements as we have analyzed earlier. They lead to these force speed requirements. The wheel radius is 0.3 meters. We also assume the electric motor type offered by the supplier has a maximum speed of 12,500 RPM, which converts to 1309 radians per second. First, we want to select the gear ratio. We use the transmission model to analyze the consequence of using different gear ratios. The total gear ratio can be calculated from this equation, which is derived from the speed equation for the transmission. If the electric machine runs on its maximum speed when the vehicle runs at its top speed, we will get the highest possible gear ratio. The reason why it is good to have the highest possible gear ratio can be seen from the second equation. It shows that the required torque of the electric machine is minimized if we maximize the total gear ratio. Since increasing the speed of the machine has almost no cost, while the cost is roughly proportional to the torque of the machine, it is clear that the machine cost is minimized if we use the highest possible gear ratio. In this first step, we select the electric machine to run at its maximum speed, 1309 radians per second, at the maximum vehicle speed of 200 km per hour. This results in a gear ratio of 7.1. This gear ratio means that the operating region of the powertrain will be limited to maximum 200 km per hour. Now we have reached the second step. Let's determine which requirement holds the highest force. It's 4,995 Newton and it stems from the acceleration requirement at 50 km per hour. Then we use the transmission model to calculate what torque the electric machine has to produce to provide this traction force. The maximum torque of the electric machine at a gear ratio of 7.1 is 212 Newton meter. So, conversely, 212 Newton meter torque will lead to these force limits for the powertrain. We are now already at the third and final step. Now let's minimize the size of the inverter by finding the power that is just enough to meet all requirements. Of all the required operating points, it is the acceleration requirement at 100 km per hour which requires the highest power, 95 kilowatt. If we require the electric drive to only be capable of delivering power up to this level, we will limit the operating region further. So we get this operating region. We have calculated which is the smallest 12,500 RPM electric drive which meets the performance requirements. It needs a transmission with a gear ratio of 7.1 and a 212 Newton meter electric drive with a peak power of 95 kilowatt. The steps we have used to minimize the requirements for a single-speed electric powertrain are: 1. Select a gear ratio leading to maximum electric machine speed at maximum vehicle speed. This will provide the highest possible gear ratio. 2. Determine the maximum traction force requirement and calculate the corresponding electric machine torque. 3. Determine the highest power requirement and make it the required power of the electric drive. What this sizing method achieves is that it uses the maximum machine speed to reduce the torque requirement on the electric machine. It then minimizes the torque requirement to minimize the size and cost of the electric machine. And finally, it minimizes the power requirement to minimize the size and cost of the power electronic inverter. Have we found the perfect electric powertrain? Not necessarily. We have found a reasonable electric powertrain with a low cost for the electric machine and the inverter. But since there are other factors besides minimized cost, there may be reasons to also analyze other ways of sizing the powertrain. Now you have learned a method to size a single-speed electric powertrain to meet a certain set of requirements at a low cost. In the following exercises, try for yourself to size powertrain components for some different vehicles. Thank you for your attention.